Hi, everybody. It's time for You Can't Do That on Salesforce. Part 3. Today, we're gonna keep building Forceopoly. I'll show you a couple things that I messed around with since last week. And I think we're gonna be able to buy properties and pay rent and roll some dice. So those will be we'll say those are the things that we're going to get through today. So my Scratch org stopped working, expired. Didn't stop working. It works just fine, and expiring is something that works just fine. So I had to create a new one, relatively painless. The source code repository. Give me 1 second here. I got a renegade screen trying to take over the world here. Source code repo has been updated. Let's take a look. I think it's updated. Let's see. Yeah, we got some updates out here. This was last night, so I did a little work on some dice rolling. We call it loopy randoms in a flow with a little bit of invocable, and we'll talk through that. For a second. And let's see. I think that was it. There was a little bit of cleanup. I found as I was refreshing the Scratch org, I realized that some of the fields didn't make sense. Mortgage value. It doesn't make sense because it is it's half of the value of the not of the rent, of the purchase price. So we can just figure out the price of that. No big deal. We'll just calculate that instead of having to have that in a field. So we'll take a look at that, and we'll get caught up, and we'll do some more building. And let's see what else is going on out here. I had to get the chat up. See what's going on out here. All right, so let's fire up this org. Get out to my Visual Studio. And start this guy up. Just poking at a couple of things off to the side here too at the same time. Failed to open Scratch org. Wait a second. Sometimes this happens. I gotta close down Visual Studio and open it up again. That all looks super weird. Operation not permitted. What? I have no idea what that means. All right, let's abort, and we'll quit and come back because that sounds weird. Let's shut down all of Visual Studio. Try again. Wait for all the Visual Studio-ness to fire up here. It's interesting to watch it load through all of the plugins and extensions that it needs to run stuff with. Just waiting. It's almost like my extensions aren't loading. Kind of weird. Oh. And the printer is running, so I can print something. Oh, here, no. Come on, extensions, what are you doing? Oh, this is really strange. Let's see, are they loading in here? This is just not happy right now. Make sure that you're connected. Well, I'm definitely connected. So what's going on here? That seemed to take a long time, and I'm not quite sure why. So let's hopefully get our org open here. It's taking a little longer. Longer is better. There we go. Whew! Making me nervous, Visual Studio. And we're back. All right. Okay, so let's talk about random. Let's talk about random in Flow. Now, random natively in Flow, as far as I know, and the internet told me a few things, and I couldn't find anything on my own, is not something that you can do. So we can lean on an invocable to do random for us. And so I wrote one, and then I made a subflow called roll for our game. So this is a dice roll that we can do now, and it's a subflow, so we can put it in other places, and that's what we've done. Actually updated the start game function or flow to include that. So here's why I call this loopy random. So this is doing a couple of, I guess, interesting things. First, it does call out to an invocable, an Apex invocable. I'll bring that up on screen in a second. Actually, let's start there. Let's find that. So here's the invocable class. Now, this is this was a curiosity for me, because I was thinking, all right, I could just create an invocable for, like get random number, something like that. Because there is a native, there's a native class or a native method in Apex. The math.random returns a number somewhere between 0 and 1, and then you can do stuff with that random number. So that is what I ended up writing that, so that we can use it. But what I also wanted to do was keep it as lean as possible, and just needed that random number, and then let the rest of the system do whatever it needs to do with it. So that's what this invocable is doing. So then I got curious, because this is where my brain always ends up going, is, well, if, why stop at math.random? Wouldn't it be nice if maybe there was an invocable that I could sort of dynamically pass the what I wanted it to call in Apex. So I basically don't need to do this again for like math.round or string.split or other things like that. Now, none of those other aspects have been wired up yet, but what I'm thinking about is a pattern here that has this Apex Flow class has one invocable called invoke, and or call Apex was a label that I applied to it, And I can pass in I pass in this request object. This is a pretty typical pattern that I use with all invocables. I have a request and a response object that makes all of the variables accessible from within Flow by marking them as invocable variables. And then I thought, well, for this case, if I want to call math.random, the class name math, the method name random, and then some set of parameters. If you look in, if I do a quick search for Apex math.random, let's look at the documentation. And we'll see all the stuff that Apex gives us out of the box. All these native methods for the math namespace. And I was using this one. Where are you? Random. Okay. It doesn't take any parameters. You just ask for a random number and it gives you one. But if I were to, if I needed some way to round numbers and I didn't have a native way to do that with a Salesforce formula or function or formula function, I might want to reach out and do some other things here, math, POW, those kinds of things. And then maybe I want to do the same in the string namespace. There's a ton of stuff in there. And I don't have this example today, but maybe we'll add one today. One thing that I would run into sometimes with flows is like, hey, I got a string and I need to split it because it's basically a comma delimited list. Or I've got a string and I need to trim it to a certain length. I guess that one's not a great example because we could do that with a Salesforce function. A Salesforce formula function, I should say. Substring, things like that. So even stuff that can be done in formulas that is really hard to do in formulas could be offloaded very easily to Apex classes. So, but rather than write single serve invocables, maybe we can build a little bit of a library here that can say, all right, this right now this only supports math.random. But if I wanted to support, let's look at another one. String.split. Let's do string.split. I have this request and it will accept the class name and the method name. Now, a lot of the methods in the namespace methods expect you to already have an instance of a string or a math a numeric value for the math class. So because I'm saying I want to call string.split, I'm not actually able, I have to pass in the input for that value. So I would do something like this. I would say, you can kind of see what's going on here. Invoke, we'll take a look at this in the flow, and we'll see that I'm passing in a bunch of requests, or I should say flow is passing in a bunch of requests. This is bulkified, so it's ready to handle multiple of these. I know I'm going to send one or more responses back, and then I'm going to iterate over the requests that come in, determine what class and method it's asking for, math.random in this case, if that's what it's asking for. I'm going to build the response with a decimal value that comes out of math.random. That's the easiest scenario. Now let's do something, let's add to our library here. I'm going to be very literal and just do a if else something else, right? So let's say I want to do string, not split. There's probably a nicer way to do this. I think like usability wise, maybe this would be, might be nice to say string class and method, and maybe we just take string dot to lowercase. We'll allow the users to do dot, or we'll have it do dot notation And we'll take the method name. All right, we'll put all that together. So now instead of having to do two layers of ifs, I could just say, if math dot random. Can take out a little bit of extra gunk here. There. And then likewise, we could say string dot split. I guess I don't even have to, whoops, I need to check this, right? Check this value, class and method, string dot split. Let's get rid of this and this. There we go. Okay, so now we have our response is kind of loaded with different potential return values, right? Based on data type, because I'm trying to apply a pattern here that, consolidates all of this into one class, as opposed to building a class for every invocable out there to do a math.random class versus a string.split class. You're just passing in the class and method names and getting back what you need. The only downside of that is I got to know how to interpret the input and the parameters. I have to sort of restrict what those parameters can be. Otherwise, I'm going to have, an input string, an input decimal, an input Boolean. So I'm making a call here to say, all right, let's just convert those to strings for the when we pass them in here, and then we can allow our code to cast them back into whatever they need to be cast to. So that should work fine for the most part. Likewise with the params, I'm being a little bit literal here and just saying, if I go back out here and look at regex, so regex has, regex string.split takes one parameter, which is some regular expression of what you want to split on. So that could be like just a comma. In our case, we've got a comma delimited list. We can break that down into multiple values. So let's think about split. So I'm going to now split's fun also because I need to return probably many strings, right? So we're actually going to make this let's make that a list of strings and say string values that we need to return there. And my input is going to be whatever I want to split. And then my param1 maps to the first parameter of the method that I'm calling. So again, math.random, it's got no parameters. We're not using any of the params. I haven't seen anything in the standard namespaces that has more than 5 parameters. I don't know if I even saw one that had 5. So we'll start there. And so for string.split, for string.split, if I were to to use an example here, I would expect something like this to be passed in. So it would look like A, comma, B, comma, C. So the parameters that I would, if I had a string that looked like that and I wanted to call string.split, my class name is string, my method name is split, and these will get lowercase, so I guess it doesn't really matter. My input is, let's just call this, ABC, right? My input is ABC. My param1 is whatever the param1 is out here for string.split. if I can find it, the regex. So that's param1, and I can say param1 equals comma. No param2 through 5, but these are what I would pass in. And then this would call, it's going to return string values because we get a list of strings back from that. String dot split, or I'm sorry, not string dot split, it's our input, right? Because we're passing in the value, so that's our ABC, and then split with param1, which would be our comma, and now we have that that accounted for. So, and we could keep building methods like this inside of this one class to basically expose Apex commands or native Apex methods that may not be easily achievable either through Flow or through Salesforce formula function to bring those into Flow. And let me push this to the org. Hopefully I got all my code right. So that was me adding another, well, almost. What did I miss here? Oh yeah, I'm going to break everything with my comment. Let's see. Oops, forgot my. Oh, right. So we're in a loop. So this is actually r.input and r.param1. And there we go. All right. And we'll push that one more time. There we go. Okay, now let's see how this works. So I added another function out here. It's not actually the one that we needed for Forceopoly, but here's what this looks like when I'm calling it. So I'm calling it here in my role subflow, and I'm passing in. You can see the parameters that are available. They are all the invocable variables from that. So my class name, math, my method name, random. I'm not passing in anything else for the to call math.random because I just want that random number. But what is returned? Oh, actually, I'm sorry. We don't need to deal with anything that's returned. We don't need to manually set that because we can just have access to it once we're done. So one other thing that you pass into this subflow is the number of sides of the dice that you want to roll. So math.random doesn't care about that at the start. It's just going to give us that pseudo-random number between 0 and 1. What I do care about is, well, how many sides does this dice have so that I can evaluate the random number in the context of 1 to whatever, right? So if I have a 6-sided die, I have space between 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6. 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6. So what we're doing is saying, I feel like I wish I could draw a picture. Maybe I will draw a picture. Hold on. I'll get the picture cam up here. Let's see. Because here's where my head was at. And this is why it's loopy too. Let's see if this will work. Picture cam. Can you guys see that on the screen now? Not yet. Okay. Let's do Let's try this. Kind of. Out a little bit. Kind of. What can you see? You can see my... There we go. A little bit more. Good enough. All right. Hopefully you can see what I'm writing. Hopefully it's not backwards. I don't know. All right. So math.random. Can you see that? Y'all can't see that. Nah. I'll just do this in a notepad. Okay. Let's turn off desk cam. So let's take a look at this over here. Here's my thinking. Math.random returns something between 0, put something way over here, and 1. Meanwhile, I have, let's use a 6-sided die as an example. My sides equals 6. All right. Let me evenly divide that. So 1, 2, 3, 4, 5, 6. Okay. I'm going to pull this in a little bit. So I want to evaluate, all right, so we know that math.random is going to put a number between 0 and 1 out there in decimal form. So if I were looking at my 6-sided die, to determine if and actually let me offset this a little bit. This would be here. I think I got that. Let's see, does that line up right? Okay, this is one. All right, so we have math.random is going to kick out a number between 0 and 1. I have 6 sides of my dice. I am going to evaluate for each side of the die, does it appear where is the random that was given to me? If the random was given to me, and let's play this out, right? So if I'm evaluating a 6-sided die, I need the pop out here, right? Here's 0. So to determine if we rolled a 1 with a 6-sided die based on the math.random number, I need that number to be between 0 and 1 divided by 6. Okay? Which is some decimal that I think it's, what is that? 0.16, just so we're keeping tabs here. Oops. Pushing the wrong thing. So something between 0 and 0.166, repeating, let's just run it out to 3 decimals, we'll say 167. Okay. There's that. So if if math.random gave me, it gives you crazy long decimals, right? So if it gave me 0.11114, something like that, that is between 0 and 1/6. Therefore, I rolled a 1. So far, so good. Let's move this out a little bit because I'm definitely going to need more space. There we go. Super high quality ASCII ASCII math art. All right, so what's our next number? Let me line these up again. This is going to make, I should have just had a spreadsheet. That's okay. All right, so my number 2, or is going to evaluate, I would do this sequentially, right? So I would test the first number. I get a random. It's this point, 1111. Is that less than or equal to 1667? Yes. Therefore, we rolled a 1. Now, if I did 2 divided by 6, which is 0.33333333. So 3333, 3334, just to get something out there. Let's imagine that my random number was this, right? 3111. So now I roll. I'm sorry, I call math random. How many sides do I have? 6. Math.random was, is it less than or equal to 1667? Nope. Loop to the next step. Is it less than 3334? Yes. Therefore, we roll a 2. And this keeps going and going and going and going until we get out to the end, which would be would be between, let's see, what's 5 divided by 6? 5 divided by 6 is like 83333 or 1. That would mean we rolled a 6. So this way, the math.random, it falls down a little bit if you on the ends, right? If you're trying to get to 1, you gotta be set some boundary between 1 and 0 with the random value that comes back. If you're trying to get a 6, if you've already compensated for the 0, you may be overcompensating then to determine if someone rolled a 6. So I felt like dividing it up like this and evaluating the defining the boundaries of the number between each side basically as a percentage of the percentage of 1 lets you say, all right, 1/6 I need to roll this or less. 2/6 I need to roll this or less. And then I can just change, from there it's just changing the number of sides. So if this was 8, my first boundary would be 1/8, which is 0.125. That one's an easier one to do. So if my random is less than or equal to 0.125, I rolled a 1. And then 2.25, 0.375, ... So let's go back over to our flow and talk about why this is loopy random. If I can find my scratch org. What did I do with it? Probably have to open it again. Oh no, it's hiding back here. There we go. All right, so let's go back to roll now. Got my random value, so that's, let's say that's 0.111. So, and then I got my sides coming in. And I'll show how we pass that in at when we're showing how roll gets used. So what I need to do is seed my loop collection. So with flow, this is you can't loop over something that you don't have values for, right? So we have to create a collection to loop over so that we can have the values to loop and evaluate with. So what I'm doing here is what I don't want to do is have to say, well, let me, loop collection. I could just add all the values based on the seed, or I'm sorry, on the sides that I need. But I don't know how many that's going to be. That's a dynamic number. So I can't confidently set this value or set all of my loop numbers that I need to loop over. But what I can do is seed it with something. It's always going to have a 1, right? So we're going to start there and seed our collection. And then, I've never done this before, but it does seem to work. I'm going to build the collection while I'm looping over the collection. So, and we'll do that this way. So you'll see what I'm looping over. I'm looping over loop collection. Now, when we get here, I've only got 1 in the collection because I seeded it up here. what I want to do is check and see if my random value is in the range that based on what we just looked at before. Because if it's in the range, I know that the number that I'm evaluating is the side that I rolled. So my test here is a random in range formula that we'll take a look at in a second. If we're in that range, then it's true, and we have a bailout method that we'll look at in a second. But let's take a look at random in range. So random in range is taking the math random subflows value. It's taking the decimal value of that, and it's saying, are you less than or equal to the current element in the int loop collection and so in my case it's 1. That's what that's where I've started with if we just kick this off, and divided by the number of sides. So we're doing that division that we were doing over here inside of this formula. So we have I'm going to switch our random number back. We got 1, 1, 1, 1. Is that less than 1, 6, 6, 7? Yes. If the answer is yes, then we bail out. And we'll take a look at the bailout here. So that's all this formula is doing, is grabbing the decimal value. This is literally our random value right here from our math.random, and then comparing it to doing the sides math division. So if it's a yes, we need to return a value. So I'm going to return something from this subflow so that flows that are consuming it have a value coming out of it. And then we're going to exit. There's nothing really happening here. I probably could have done this on the step up above. So I'll probably fix that, but we're not really making any change here. We're just saying, all right, we're done. We're going to the exit step. We don't need to do any more here. If our random number was, let's go back to 0.331, and we're still dealing with a 6-sided die. All right, the random was not in that range. So in the first iteration, 1 divided by 6, it's greater than that. So, and that's what our formula was testing for. So it's not greater than, or greater. It's not in range. Let's go to the no condition of that decision, and we're running a decision here to make sure that the current item in our loop, which is 1 when we first start, is less than the number of sides, because we don't want to just keep adding numbers forever. So 1 is less than 6, so the answer is yes. So let's add a value to our loop collection. Now I've created a increment loop counter here value so that we can basically take the size of the loop collection and add 1 to it, right? So this is how we're able to to just count the number of items in our collection. So it doesn't necessarily even need to be like the number 2. Like we could just we could add whatever value we want in there, but just so it's not insane, we can use it this way. So I'm incrementing that value, and now before I exit, lo and behold, by the time I get back up here, I now have another item in the collection. So Flow will evaluate that one now. So I can within a collection add items to that collection. That was kind of part of my test in theory as part of this random loopy thing that we're talking about here. Can I keep... I know that I need to evaluate up to 8 sides based on the random number. Can I add evaluation items in the collection until I find it, and can I do that dynamically? Because I don't know the number of sides that are coming into that are coming in. So turns out it works. That's cool. Let's debug it and make sure I really am not talking crazy to y'all. So here's my sides. This is a parameter that gets passed into this subflow. So let's do a 6-sided die. and run it. And let's see what our final, got to find our value here. So our math.random returned 0.823. So it looks like it's going to give us 3 decimal points for our random value. That's a pretty high number, so we can see that, you know, the do add was called multiple times throughout this. So we got up to 5, and then we determined that was our random in range? Yes. So we set the return value to 5, and then we exited. Now, just for sanity's sake, does the math check out? 5 divided by 6 is 0.833. Whew, that's close, but it is 5. So, or I'm sorry, it is less than 823 is less than 833. So it's in the range of 5. And if it was 0.843, it would have been a 6. Let's run it again with a 6-sided die, just to prove that we're not, you know, lying to ourselves here. Well, we returned a 5 again. What was our initial value? 709. So again, if I look at, you know, then I want to look at the if 5 divided by 6 is 0.833, that's the top end of the random. So what's 4 divided by 6? That's 666, 667. So 700 is between the 4 and the 5. So we're calling it 5. And there's as I talk through this, there's probably a more efficient way to evaluate this, but you know, we've got somewhere to start here. Let's debug again and see if we can get something that's not a 5. So our random this time was 0.612, so this should be a 4. And we're returning a 4. Once more, just for fun. 0.186, I think that's going to be a 2. And it's a 2. All right, so instead of doing some calculation with that random decimal, I'm using it to set, I'm using the die sides to evaluate that value as it steps through. Basically check each, you know, hey, are you a 1? Are you a 2? Are you a 3? Are you a 4? Are you a 5? And that's what our, you know, our loopy, so there's our loopy random situation. Just checking up on a couple of things here. Still got to do a little bit of work during the day. All right, so that's a couple things, right? We have we now have a flow, or I'm sorry, we have an Apex action that we can get a random number from. We can also get other stuff from it, but we'll play with that another day. Now, where do we use this? Let's go back to our start game from last week. Create new game. And let's go. Oh, I don't know if I saved it yesterday. I'm sorry, it's not create game, it's take turn, right? We do need it in create game eventually so that we can decide who is, have each of the players roll and decide who goes first. But let's look at take turn. All right, so we can see what has changed here. So when we were talking last week, we were taking a turn. We're creating turn records so that we can have a queue of turns that need to be evaluated and some values on them to decide what the outcome is. And last week we were just faking the roll. Everybody was getting a 6. So now that we have this roll subflow, I've replaced just giving them a 6 with actual rolls, and we've got two. So we're rolling 2 dice. So I'm rolling technically twice. I'm calling roll dice 1 the first time. I'm telling it I'm rolling a 6-sided die. I'm calling roll dice the second time. I'm telling it I'm also rolling a 6-sided die. So that's like me dropping two 6-sided dice onto the table. And what are my results? I can determine 2 things from here, and I want to set the value of my turn. What did I roll? So I have a roll total formula. We'll take a look at that in a second. And I also have I can determine if it was a double if roll 1 equals roll 2. So we've got a couple of things that we're able to do here. So I got a roll double formula, roll total formula. Let's look at those. Roll total just checks to see if the returned value of roll dice, that was that value that we're passing back, is this, or I'm sorry, this is for total. So we're taking roll die 1 value plus roll die 2 value. That's our total steps. And then we are looking at roll dice. We want to look at roll double. So we're just evaluating if the values are the same. So if you roll 2 3s, 2 4s, whatever, we can get our did you double or not from there. So took care of those two pieces, and we've got now we've got rolling. So that's cool. We're setting both of those values on the turn, and that is double. That is rolling, and that is random in a flow, with the help of a little bit of Apex. Again, there might be some really esoteric way to do a random in a flow. I think you can wield flow for good, and sometimes you can wield flow for strange. And I didn't want to end up with a very, very long, very, very esoteric flow to calculate, what's available to me in formulas. Maybe the interview ID plus use a date to seed something random plus a few other things. Like, yeah, that could work. Or maybe we could just call out to a standard Apex method and get the value that way. And now we've got this interesting kind of model here where I can add as I need more of those calls. Again, I recognize that our parameter passing is a little suboptimal because we have to cast in and out of strings to make it work. It'll work great for the string fields, but we might have to do a little bit of interpretation here. But it's fairly easy to add more from this. I don't have a unit test written for this right now, I confess. You'd have to add more of that as time goes on too. But kind of got the engine wired up for all of that. All right, so when we last met, we were... one other thing. I updated... I have to give credit to this. I didn't do that yet. But we have the properties in a CSV file now with all the relevant values that we need, so that when I stand up a Scratch org, you can just call... I put in a shell script here that uses the CLI to insert those properties in bulk based on the spreadsheet that they're in. So I believe all the pathing is correct there. So that was a quick and easy way to get all of the data in. One thing I added to support that was an additional field on the property object. So there's a type field here now, which is just a text field. It's redundant to the record type name, but knowing that record types will change the IDs will change every time you get a new scratch org or put it into any environment, it would be difficult to seed the properties and give them their type with the import file without knowing that. So on one hand, I guess I could have my script could have been more Apex based and read out the properties and I could do some work to the to the startup script to populate it. On the other hand, I just could create a field and tell it that what record type each of these is, and then the type field now triggers a flow that set record type from type on the property object. This is a very boring flow. It loads up for each property that gets created or updated. It checks to see if it doesn't have a record type and does have a type value set, it will go find the record type that it needs to apply, and it will do that. So just kind of a one-off single purpose flow there. Okay, so let's take a quick look around. Anything going on in the chat? No. Okay. Anything going on in the rest of the world? All right. So that is we've got that added to the project as well. Okay, let's get back into pick up where we left off here. So we're still taking turns. We rolled. We determined if it was the first turn of the player. So we have this previous player turn property on our game properties, and on our turns. And if it doesn't have a previous player turn, then we know it's their first turn. And we set the position to whatever they rolled, or we set the position to this formula that bases off of their previous position. Where should they go? And then calculate position was doing a little bit of logic to determine if basically did we cross over go or not. So I hard coded the 40 here. It probably would make sense to query that out, but I think we're going to survive with it being hard coded. So then we left off with wanting to load a property position. Wanting to load the game property record for that position, which is what we were doing here. So we figured out our position, and now we're querying this out. So from here, we need to determine if the property is bought or owned by somebody, and if not, we need to buy it. So what do we need to do to make that happen? We need to check the owner field of the. Let's bring up that object actually while we talk about it. We want the game property object. Owner is a custom field that looks up to a player. And we want to evaluate that to determine if it's blank, it's not owned. If it's not blank, it is owned. Is it owned by the person who rolled it or who landed on it or not? So it sounds like we need a decision tree here to figure out what to do next. So let's start a decision, and we'll say game property owner, and we'll say none. Copy this down. Let's add another outcome, which could be current player. And let's add another outcome, which could be not current player. All right, so we are, now this just makes me think about something. I wonder if we're going to have to do this logic here. I wonder if we're going to be able to do this. So none, easy condition, right? Game property dot player, oops, dot owner, sorry, is null, true. Okay, here's one condition. If it's the current player, then it's the game property. I think this is where I'm going to get tripped up. Owner equals, I don't know if I know my player right now. We need to be able to pass a player into this, or no, our turn, load turn, player, right? There. So if the this property is owned if the game property owner field is the same as the turns player field. And then we're going to do one more condition here, which is if it's game property owner is not equal to return player. Now, did I do this right? Is Flow going to evaluate in this order? I think it will, because I can move these. For each path the flow can take, create an outcome. For each outcome, specify the conditions that must be met for the flow to take that path. I am hoping that it's going to say, because if it doesn't come in and say null is true, it's going to come down to not current player, and it's going to evaluate this to true, which we don't want to have happen. I can add more logic here to do a not null and maybe I should do that. But I'm kind of curious how this will evaluate in the way that it is. So let's find out. So we've got three conditions. So if the property is not owned by anyone, I think we can be really heavy-handed and buy the property. We could, or we can just indicate. Did I make? Is this a? I think this is a screen flow. Is that right? Yes, this is screen flow. So I can show a screen. So let's show a screen that says. Before we get too heavy-handed, right? We need some user input. That says. This is screen 1. Oh, no, it's not. This is screen 2, I guess. Screen 2. Let's put some text up here. So, display text 1. Nope, display text 2. Let's see. This property, we can merge that value and make it a little bit nicer. Oh, wouldn't it be cool if we could like show it in the screen? That would be a great Lightning Web component to build later, I think. So this property, whichever one it is not owned by anyone. Would you like to buy it for something? Money, dollars. And let's say if you do not buy this property, it will go up for auction. I don't think we're going to build auction today, and that's okay. I think that'll be a fun one to figure out how to build. I think it's basically another. We might be able to use the turn model to pass the to pass the auctioning action up for others to review. But we'll think about more of that later. So we're gonna say done here. Actually, we probably need like a checkbox or something, right? To say like, yes, I'm gonna. Let's do radio. Radio. Boop. And let's see. Radio 1. Yes. And no. Enter a valid value. Okay. Oh, whoops. Don't do that. Let's make a new choice. This will be we'll make this a choice. Let's call this radio. Yes. Yep. Let's make another one. Radio, no. Say nope. As I'm thinking about this, I'm wondering if this is actually data that's useful on our turn. As a, it's a potential action that was, or a decision that was made, and an action that was taken. So I'm just writing down some ideas about potentially more fields on our stuff here. I'm going to keep this crazy thing because maybe it's useful again down the road. But our turn object, do we want to store by decision? That might be useful. If we do that, the other maybe nice side effect is we might not need all of this flow UX. We might be able to just use a field, the field beta function there. So, but for now, we'll use radio yes and radio no for that. And now we have something to evaluate after the user comes in here. I probably should use the default value, or make a default value here, right? So let's say it's radio no. Try not to lead the witness too much, but we need to have something in there for them to work with. Okay, let's, so we took our turn. We would have a decision here. I'm going to take the happy path and make a decision. Let's see. Decision to buy. Yes. And that's if our, what do we call that, radio 1? I didn't use a very smart name for that. Radio 1 equals radio yes. And then our default outcome is no. Well, we don't even need to change that. Oh, darn it. Darn you, escape button. Decision to buy. Yes. Decision to buy, yes. And radio 1 equals radio yes. And otherwise we have our default. So, okay. Happy path. We are gonna buy it. So if the answer is yes, what do we need to do? We need to assign let's see. I want to buy the property and no one else owns it. I am going to assign the owner of that property, and I'm going to deduct the amount of money that it cost from that player's whatever the field is on the player record that represents their balance. So I feel like there's some more turn fields here, like emerging. So did we decide to buy, you know, what was the transaction amount? Right? So if I was buying Broadway, that would be, you know, minus $400. I feel like that'll be interesting, you know, interesting data to have, and then we'll also deduct that amount from the player. Let's see what that field is on the player. This is game property. Let's look at player. Money. So we do need to, I think something we need to evaluate before the before we make the purchase is, well, what if you, let me add this to the backlog, right? Because I think we can, you know, we'll keep going down the, you know, the happy path here, but we need to evaluate, you know, player not enough money. So we need to, you know, it's great that you want to buy Boardwalk, but you've only got $200. You can't buy it. So, you know, we start to get into some mortgaging questions at that point. Or there's also a do nothing, right? So the default outcome can be, you know, if I don't want to buy it, it would take the auction path, right? But let's so we'll need to keep that in mind. I feel like there was something else that just kind of came to mind there. Well, we'll come back to it. It'll pop back in my mind again. So, in the meantime, let's do this. Let's do these assignments back here and take turn. So I probably should create a new player instance in here. So I have the game, I have the turn. Let's init a, actually I don't even need to init a player. I can do it this way. Let's make a new resource. We'll make a variable called player. This will be a record of type player. All right, and then we'll instantiate this based on data in the turn. So I'm going to assign init player ID equals turn load turn dot player. Okay, then player let's get the money equals load turn player money. Okay, so now I have something that I can save and something that I can make changes to with what's going to happen next. So, all right, we're done there. We've got a player record. We'll come down here. If the decision to buy was yes, still happy path. We're gonna update a few. Let's see, buy assignments. So we got to do a few things here. We need to. Oh, we're gonna need the game. Did we load? We already loaded the game property. Yeah. So the game property owner equals my player ID. and my player money subtract game property dot property dot property cost. Done. Okay. So we did some by assignments, and I think that's it. I did my buy. Now I can do, there's other stuff that I could do, right? We got another phase of you could decide to build houses, build hotels, etc. We put that on the backlog, right? Adding houses and hotels, that's off in the future. But this could, if this was the simplest path through here, I bought the property, I didn't roll a double, and I'm done. So this works, this satisfies that scenario. What about the rolling of the double? We would want to add another turn to the for the player so that they can take another turn and roll again. So that tells me, let me save this. If I look at my flows, my create new game has some it has some turn making stuff in it. So insert first turn, and then where do we, I think that's it. Let's look at that. Just the game and the player. Now we need to know, there's two conditions at the end, right? If I roll the double, happy path, I go again. If I roll a double 3 times, then sad path, I go to jail. But for now, we'll assume happy path, and I'll if I rolled a double, I'll roll again. If I didn't roll a double, I create a turn for the next player. So we'll have to figure that out. If this was more complex, I might, and we still might, put this into a subflow if it's something that we can use over and over again. But for right now, we'll leave it here. So let's go back over to take turn, and let's do some more. Let's ask ourselves some more questions. Did we roll a double? Roll double? Can we be even more generic? Maybe like end turn decisions, right? Because we could have, right? We could have roll double less than 3 times. Roll double not 3 times. How's that? Roll double not 3 times. I like that. Okay. We got roll double 3 times. And then we've got no double. Okay, so no double's easy. Roll double equals false. Roll double not 3 times. Roll double equals true. Oops. And we're going to have a little bit of fun here. I'm going to reference this. Load turn is roll double equals true. I like that a little better because that's the thing that we're using. Right, we're setting it up above. So load turn is roll double equals false. Now this one, we're going to add a few more conditions here. So load turn dot previous player turn. Actually, I want to do the other one first. It'll be a little easier to, again, I would like to do this, right? I'd like to put this, oops, above the, stop it. Do it in this order. So hopefully it would evaluate and say, oh, you rolled double and load turn previous player turn. So the prior turn, right? They also rolled a double. And then the prior turn, they also rolled a double. So previous player turn is roll double equals true. So, whoops, we can figure out our outcome from from that. So again, I'm hoping that these are if else if kind of logic evaluations from top to bottom, because then I don't have to do. I just put that on the wrong thing. I'm gonna just change the names. Let's just call this one something for a second, and then actually no, we'll call this one. Right, so this one is actually, this is our roll double 3 times. Keep our API name square. I want that to evaluate first, and then roll double not 3 times. We'll evaluate that second, right? So this is just, did I roll load turn is roll double, still true, but I'm not in the danger zone of 3. And then is it false? I did not roll a double. All right, cool. We're getting somewhere here. Okay, so no, I feel like the easiest path here is no double. If I didn't roll a double, it's the next player's turn. So we would insert next turn, which is let's say insert next player's turn. And so we're going to put that. We're just going to insert 1. We're going to make a turn. Oh, whoops. We'll use separate. I don't have this iron existing thing here right now, so the turns game is what do we have that represents our game here? We've got the current turn load turns game. It's the same game. Okay, and now the player is going to be a different player, so we may have to do. We're going to have to do a little bit of logic around that. Let's come back to that. So that's our no double condition. If I did roll a double, then I'm going to insert current player's next turn. That's insert current player's next turn. Okay. And that's going to be another turn record, and it's going to be this game. It's our load turn game. Okay. And then our player is going to be the same player. Okay. So I want to insert that, and then I do need to do one more thing, which is tie the turn that I'm on. So I just made the next turn for this player, but the turn that I'm on currently needs to be the previous player turn and the previous turn on the on this record. So let's see. I can do the. Wait, did I say that right? Oh, I can set them here. Duh. This is the next turn. So the previous turn is this turn that we're working on right now, and the previous player turn is the same thing. Right, so that keeps our history alive. We keep evaluating that. We do need those on the other side here too. At least the previous turn is this turn. Okay, there we go. And then previous player turn, for this one, for a different player, we may have to do a little mojo to figure that out here. But that's okay. So we got that going too. Let's see. Not ready to do the roll. I'm not ready to send him to jail yet. Then I wanted to look at the start of our turn, because we need to determine if the turn is like done, right? So this turn is, by the time we get to the bottom there, this turn is over. But what tells us that the turn is over? Is there anything about the turn record that says, yeah, well, you're done? Let's see. Do we have any fields that help that? Turn fields. We do not. We need somewhere in this to indicate who's got the current turn. Can we do that on the game? Maybe we should do that on the game record. And then we could yeah, we could do that on the game, I think. Sounds good to me. Let's do it on the game. So we'll go to the game. I think that makes sense, right? You can only ever have one person taking a turn at a time. So unless there's something on the game that I've forgotten about, let's take a look. We have active player. That might not make sense anymore. Active turn or current turn might be a better take on that, because the turn would imply the player. So if we at the end of our turn decide what the next turn is, I can also tell the game this is the next turn. I feel like it would be helpful for the turn to also know that it's, you know, that it is the active turn in that game. Because if I'm playing, 5 games at once of Monopoly in my org, I would need some way to know that, hey, these are the, if I could go to a list view and see like what current turns do I have to play, that would be easier to do that way. So I think we make a current turn field on the game. We get rid of active player on the game, and then we create a is current turn field on the turn, and we turn it off for the current, when we're done, when we check it for the next one. So that's my plan. I think we're going to do that in a few minutes because I'm going to go get a drink and be right back. And we're back. We are finishing a turn. We need to add some fields. Let's add a field called current turn to the game. Make that a lookup. Call that current turn. And that will be, let's see, a child relationship. Current turn. Turn games, I guess we'll call that. Update our permission set in a second. Leave that on the page. Current turn games, which we're not going to display because it's not really relevant. Okay, and then I think active player goes away. Unless we're using it. Are we using it anywhere? I don't think we are. Just 2 layouts, so I think we can get rid of that. Current turn will tell us who the active player is, so we don't really, that's redundant. Okay, now let's go to our turn. And we'll make this a checkbox and say current turn question mark, or is current turn in API speak? And I'll add that to the, sure, we can add that to the turn layout. Is current turn. So let's go back to our take turn. Is current turn. So let's go back to our my monitoring computer. I forgot to turn off the sound. There we go. We're taking our turn. We're rolling. We're buying. We're ending. So we should reload this because actually before we do that, we got to update our permission sets. Okay, Forceopoly admin. I was thinking that a lot of the flows are the only times when users should be able to manipulate different objects that they normally wouldn't have access to. So we might be able to have a fairly locked down, like read-only level of access for a Forceopoly player. You know, my admin is really just here for configuration purposes, but we'll see how that goes. So we updated the game. Removed a field and added a field. And we updated the turn. Moved field or added field there. So now we can go back over here and take turn. end our turn. We'll also have to update the start game and mark that as... so this is the new turn. Make that true. Also the next player, which I know we're still figuring out, but we'll make this current turn true. Okay, and then we'll probably need some. We'll need some logic in this to prevent the flow from running if it's not the current turn. Let's backlog that. Stop take turn flow if not current turn. We probably should stop take turn flow if it's not the current player too, right? Fair. Yeah. Okay. The other thing we need to do is tell the game what the current turn or the current what am I trying to say? what the current turn is. So we'll do that at the bottom of each of these. Let's update a record. This bottom is probably should get a little bit more elegant. We should probably be instantiating a turn at the before the decision, and then saving it afterwards, because I'm getting pretty redundant in the in the logic department here. But I'm going to keep rolling with it, and then we can always refactor later. Sorry, gotta do a little okay. All right, where were we? We're gonna update game current turn. So we're going to update a game with ID equal to, let's say this turn knows about the game. Here we go. And the current turn is the one that we just created for insert player's next turn. So the ID from that, okay? I have an error. Or did I forget? Oh, duh. I need to put that down here. Current turn is turn ID from current player's next turn. There we go. And we'll get rid of this. Okay. And we can also do that over here. I'm just going to copy this. This turn is a different one. From next player's turn. Again, we still haven't figured that logic out yet. We could probably, because our turn is loaded, we've also set some fields on it. So we can, I feel like we could do that pretty early on, right? We can go up here. That's a knitting the player. We set the roll results. Let's be very explicit about this. I almost cheated there. I think what I'll do is down here say we'll do an assignment that says mark uncheck current turn. So for our load turn is current now equals false, right? And then I feel like I can save it at that point as well, because I don't think we're doing anything else with the current turn being the turn that we're looking at in this logic here. So we'll turn off the turn, if you will, and we'll update that. And that's our turn from load turn. Okay. All right, let's review. We load the position, we determine the ownership. Nobody owns it. Do you want to buy it? Yes. When we buy it, we set the game property to the player. We set the player's money to, we subtract the amount of the purchase. We uncheck the current turn. We update, we save that. We decide what is the next turn for this player. If they, I just realized I had all these in roll double 3 times. I'm going to move them now. I don't love copying stuff. Oh wait, because it makes kind of a mess of the names. But man, I've had a hard time reading this today, which is probably an indication that I'm not making the best naming convention decisions. That's okay. Let's just delete these so we don't have any confusion about where we... stop doing that. Delete that. Oh boy, here we go. Take game turn. What does it depend on? Oh yeah, we got to change this. There we go. Okay. Roll double 3 times, we should be going to jail. And roll double not 3 times, we should be putting in another turn. And what else have we updated in this flow that is starting to get a little intense? We're not really done yet. I could see end turn becoming its own flow, where we would pass in the turn and maybe the player in the game to finish everything out. But for now, we'll keep it kind of ugly. So we're going to uncheck our, let's see, we unchecked our current turn and we updated that. We updated our player's money don't think we're doing anything else with that. Let's add a field to our turn. Let's add these two fields to our turn so we can track the transaction amount. Is that really needed? Because what we don't know right now is what happened on that turn. Exactly. I mean, we have, I'm trying to think like the action of the turn was a buy. And that would kind of be the end of the turn, right? No other actions can take place, I don't think. Other actions can take place. If I land on something, if I land on someone else's property, which we'll do next, I'm going to pay rent. So I'm going to, that's another outcome. But anything, I don't know if we have to track actions around. Well, if we wanted to be thorough, we would want to track actions around the purchasing of hotels and stuff. So maybe we have. Let's start, instead of doing a transaction amount, let's do a pick list called outcome, I think. What's the outcome of the turn, right? So you buy property. You pay rent. We'll start there. Those are the two that we're kind of dealing with. I'm trying to look at this. Whatchamacallit, this turn object as a kind of like a transaction and an audit log. So let's think in those terms as we go through this. So buy property, pay rent. We'll leave those two. That's it. For now. We'll do more later. For logging purposes, if I did buy property, I probably want to know what property was bought. Unless, do we have anything else like that? We have the game property. Yeah, we already have that. So we know where we landed. Therefore, if we landed here and we bought the thing, then it means we bought that place, which then means that we know the transaction amount if it's not an auction. So we'll hold on the transaction amount for a minute while we figure that out. But I buy property, and it is the game property. Let's make sure the game property is being set on our turn when we, I believe it is. We take our turn, because up here, yeah, we're setting, that sets position, and then we load game, property here, so then we need to set that. We need to set game property on turn. So our turn that we loaded, its game property equals that. So we got that now. Okay. And then, because we know that, if we know that and the outcome was buy, I know when that property was bought and how much the transaction was. So I think we're going to be good on that until we determine what auctioning means. Let's do a save here. Let's check our permission sets and make sure I can see the fields that I just created. So there's outcome. I think that's our only new field. We'll do a quick pull down from here. We got everything. Okay, yep. Got our updates, and we did a lot of stuff today here so far. Okay, so we are back over here. Let's look at our turn again. So we turn off current turn. We've set the game property. Let's update our outcomes, and everything else is good here. So we take turn. The turn. Oh, we need to refresh because we don't have our latest metadata in here. That's okay. We save that. Let's refresh this. All right, we are buying. So here, our turn outcome equals buy property. So we got that accounted for now. A lot of logic in here. Honestly, a little tricky to. My uranium water smells funny. I don't think I'm gonna drink that one. That's a little weird. Okay. We'll put you over there. Weird uranium water. I will forget and try to drink that in 30 minutes, I guarantee it. A lot of logic in here. Probably should be broken up a little bit more. Hopefully we'll find some logical places to break this up, because yeah, it's getting a little crazy. Okay, so we have our, let's talk it through. We're loading the turn. We're getting the player that's related to the turn. We are showing a screen Click next to roll. Maybe we should throw another screen in here that shows them what their roll result was. Let's do that. I think this is screen 3. And say you rolled a roll total. Oh, darn you and your merging. You rolled a roll double. Or no, not a roll double. You rolled a roll total. Why does it do this? Why is it so miserable? Here, I'm just going to pop it in myself. You rolled a roll total. Let's see. I just realized you don't get to do anything on your turn on your third double. You get to go to jail. And that's the end of your turn. So I think that's probably another outcome of a turn, right? Let's add that to our go to jail, right? And if that's the case, you're done. We short circuit to the bottom of the this is, yeah, that make, all right. Let's do this. Let's add another display text. We can have a little fun here. So this is what, DT4, I think. You rolled a double. We only show this if roll double equals true, right? And then we should probably add I think we should make a formula to determine if you're going to jail. So let's do that. I'm actually going to move this down a field, or I'm going to move it to after here. Oh man. Paste. And delete. Okay. Because then we'll have all of our, let's make a formula. Is going to jail. Or we'll just say going to jail. Going to jail. Boolean. Load turn is roll double. It's true. And load turn previous player turn is roll double. Probably don't need those is equals trues, but that's okay. And can I get away with this? There we go. If those three are true, you're going to jail. So now we can use that. We can use that here. For 5 here, going to jail. And we'll set the component visibility to going to jail equals true. All right. So then we probably could use this condition here with an outcome of, if you're going to jail, we are skipping all this and going here, updating the turn. We really don't need the roll double 3 times because we're sending you to jail. Right off the bat. So that the one thing we do need to do is get the property that is jail, so that we can set that for the turn, because I think that's, you don't go anywhere in that case. You go to jail. So we'll have to have another value, or do another query for that. Okay, so let's update that. Again, I think we can get rid of roll double 3 times because we're going to handle that. So we don't need roll double 3 times. We're just going to call this roll double now. And then do we need... I don't think we need this other outcome. We can just use the default. But I don't want to lose the stuff that's under it, so we'll leave that as is. Roll double, no double, default outcome. And then let's change this a little bit. We'll call this turn state. We'll say this is, we'll call this first turn. Okay, and let's add another one called 3 doubles. Or let's say going to jail. Alright, so going to jail, or first turn, or the other outcome. So, and this would be going to jail equals true. And going to jail, I want to connect that down. I don't want to do any of that. I just want to uncheck the current turn. So skip all that, uncheck current turn, and we're moving on. Is there anything else that we do? Well, actually, let me undo that, because we do need to load the game property by position, so we should set the position to jail, which I think, let's look at our data. Where are you, jail? Go to jail. No, jail. Because we rolled, so yeah, it's 10. Okay, so let's do that instead. Let's set position to jail. Okay, and then we load the property by position. We set the game property on the turn. Then we can go to jail. Because we'll have everything we need set up on there. So let's do decision. Going to jail, question mark. Do we need to do that there? Maybe we can do that in the decision tree down below. I don't want to muddy up that decision step with a different purpose, because it's really just evaluating the owner for buying for a buying or paying decision. But it's really evaluating outcome, right? I think we could change this. Let's say evaluate outcomes. Let's say no owner. This is property, no owner. Right. This is a property outcome, which is owner is current player. Okay, and then this is property outcome, owner is not current player. Okay, let's add another one that is 3 double roles, or I should say, jail 3 double roles. So this is kind of coming together. Like this is the step in the decision tree that's going to branch way out with that sound effect, and give us places to evaluate logic in all the cases. So let's move this one way up and go to jail. Going to jail equals true. Okay, so now we're going to, we don't really need to do anything else. We can just go down that path, uncheck the current turn. I like this. Okay, this is the pipelines are starting to make sense now. Uncheck the current turn, update the turn. Like it doesn't matter what you let's update the logic here, right? So we can say roll double, not going to jail, right? Or actually, maybe we just want a going to jail path here, because then we'll put that back in. I know we got rid of that, but I do need these things to run, right? And then I can just have another path that doesn't do anything for the go into jail condition. Keep my API names clean. Okay. Going to jail. But wait a second. We can't do that. No. Because we need no double. Duh. We need no double to. We gotta get rid of this. Right. We need. If I rolled a double and I'm not going to jail. Right? If I rolled a double and I'm not going to jail, then I get to go again. If I didn't roll a double, it doesn't matter if I'm going to jail. You know, it's the next player's turn. In fact, if I'm going to jail, it's definitely the next player's turn. So then we have that. We have that built in. Okay. Let's save. Turns out going to jail was a little easier than I thought it was going to be. I probably should never repeat that phrase again. We also have a pass-go situation. So, which is here, actually. When we... our formula... to set position to formula knows if we passed go or not. Or we may need to add a some logic here. So calculate position, we can use, I think, to determine if we passed go. I think we also could just do a comparison. We want to do that early on though, because the we should have that money before making any outcome decisions. So let's see. We do our turn. Are we going to jail, or is it our first turn, or is it anything else? Then I think in here, because we're setting, we're doing that formula evaluation, we probably can. In fact, maybe I should flip this around. That formula, calculate position. It doesn't tell me. It's just evaluating to true or false, or I'm sorry, it's evaluating to a number. Well, I think no, we could do like if the previous turn position was less. Wait. If the current turn's position is less than the previous turn... No, that doesn't mean you passed go. I think we have to just do this logic and say if the roll... Boy, that's interesting. This is an interesting question because I'm trying to think, is there anything that would move you? There's no card, action, movement, whatever in Monopoly that would take you around the entire board. I don't think. I'm just trying to think like if the previous position is greater than the current position, can that can never happen. if I said go to the only time your current position is less than your previous position is if you pass go. Right? What could happen? I would be on the community chest that's right before right before Boardwalk. And if it said advance to Boardwalk, then I'm going one step ahead. If it said advance to Go, then I'm going two steps ahead. It would never take me around the whole board. If I was on that community chest and it said go to St. Charles Place, I'm going to go 12 steps, and my now that would be the question. I would land on that position. We have to think about advancements, right, that move us around the board. But even still, I would have come from a higher number, gotten to that community chest, gone to St. Charles Place or Marvin Gardens or Indiana Avenue or wherever else they send you, or the nearest railroad. Those kinds of things would have to, they'd all have to pass go. If your current position is less than your previous position, you passed go. I think so. Let's go with that. There's probably an exception, and we'll have to figure it out, but okay. So it's not our first turn. We're not going to pass go, I don't think. We're going to have to determine if a card... So, speaking of a turn, if we have... If I roll a 3 and I go to community chest from go, and then it says go to St. Charles Place, I think our position ends up being St. Charles Place for that turn. It could end up being community chest, it could end up being St. Charles Place, but we always use the final position as the turn location. I think that's right. I don't think you can do multiple chances in community chests in the same turn either. I don't recall that ever. I don't think that's possible. I don't think you ever advance to a chance. I have all these rules written down. I just am not looking at them, so I probably should. Hey, let's look at them. But for now, we're going to go with the rule that if your position, I guess the only time that would happen is like, what if you got to community chest or chance on your first roll and it said advance to go, right? So if that happened, you would your position would be go. That's an edge case, I think, because we would have, let's see, I roll, I go to chance, it says go to go, so I go all the way around, I hit 0. That should be a... There's some outcomes of the chance cards that we have to think about. So, okay. I'll have to think about that one, yeah. For now, though, let's give some money. So we should look here. And we'll set make a decision. Past go, question mark. Yes. Past go, yes. And this is load turn game property position. Oh, property position. We could use that. Is less than load turn previous player turn game property position. Or do we need to do that further down in the... Because we can evaluate this any time, but we do need to evaluate it before we do any kind of buying. We need to have kind of like a chance, a card phase, I think, that would move us to our final destination. So I think we should do our money giving after the card phase, because the card phase is going to tell us what we need to get. Let's see. Stream's looking a little light. There it goes. Okay. Okay, so we should move that. We're going to anticipate some kind of card phase. So I load the game property, and before we do property outcomes, we should do card outcomes. And those might be different types of outcomes that happen on the turn. I gotta look at the card. Chance cards move to a specific property to the nearest railroad utility or backspaces. You get money from the bank. You get money from players. You pay money to free parking. You pay players. You get out of jail or you go to jail. You don't move to another you don't ever move to another chance. So you're only ever going to have one card interaction in a turn. So I think we could capture that as part of the turn, and but ultimately use the last, the final location as the because the final location could be you're sitting right on Community Chest, or it could be you're sitting on St. Charles Place. So okay, so we have a move phase. We may have a card phase, right? Which I think is we set the game property on turn. I don't think we do that yet. I don't think we do that immediately. I think in here we have card. I'm going to get rid of this pass go because I don't think it's here. So we delete that. Delete everything. Yep. Okay. So whoops. I'm going to go. We load our game property, and then we have to determine, is there, is there a card phase, right? Card phase, Community Chest. Oops. This is the game property that we loaded. Its properties, record type, name equals Community Chest. Okay. Copy this. If it'll let me. I'm going to break out Community Chest and Chance because invalid, sad trombone. Yeah, gotta go all the way. Load game property. Record type. Name equals Chance. Okay, and then the default outcome is none. Let's do this. I'm gonna do two different. I'm gonna do a Chance and a Community Chest because that'll give me a little more flexibility when we pick the card. We've got two different piles basically for those. We haven't really built any of that out yet, at least not game cards. So we'll have to. I don't even know if we have a card object. I gotta look at that. Let's see. Or maybe it's a property. Maybe a card is related to a property. We'll see. Haven't done much of that. Haven't done much with the cards yet. Know that we need to deal with them, but don't have a plan on that yet. That's okay. All right, so we do Community Chest or Chance or default outcome. So we're gonna have to. I feel like draw a card is a really good subflow to have potentially. We need to. We're gonna have to get into that fairly soon because we can't arrive at our final property without it. So But at least in the card phase, we each of these may result in another move, so we would have to reload the position, or otherwise we don't do anything. But once we know that final position, and I think we're going to need a variable for position or for game property, because it'll change. It could change down these two paths but stay the same here. We want to reference it down below. We would set that on the turn, and then we can make a go phase decision. You know, if we passed it, or passed or landed, then you get money. Otherwise, you don't. So let's call this decision go phase. Probably should put a description in here. It's like for determining if player landed on or passed go. I've seen a house rule that if you land on go, you get double land directly on go, you get double. You get 400 instead of 200. So we could probably build that in also. Let's say landed on. Landed on go. Passed go. And nothing. Right? We did not pass go. So if we landed on go, then the see, we really do need that variable in here. I'm going to do this for now. Property by position. Well, actually, we could just use position, right? So position equals 0, right? And then this would be if turn load turn load turn dot game property position is less than load previous player turn game property position, right? Then we passed it. We went from 39 or 40 to 5, right? And we can't possibly go. We can never lap ourselves. So this is a safe. I think this is safe logic. Come on. Or we didn't do anything. Let's see. Okay. Card phase, go phase. Did we land on go? We will adjust the player's we'll give player 400. Right, so the player's money, add 400. You pass it. Let's give the player 200. So the player's money, add 200. All right. I think we'll wrap it there, because let's see, these phases are now coming, starting to make sense, right? So we have like a roll phase. There's some outcomes of the roll where we can go to jail, or we go make our first move or go somewhere else. We have a card phase potentially if we land on a card property. That might not even be maybe it's not even card phase. It might be land phase, right? Because what if we land on go to jail, or we land on free parking? So let's change that. This is a land phase. I'm going to add one more here. Go to jail. So if our game properties record type game is, I think it's go to jail. Let's check. Oops, record type. Go to jail. Yep. If we land on that, then we're going to jail. Then where else can we land? Well, free parking, but that doesn't result in them. So I think the land phase is like I'm evaluating secondary move, right? So if I land on go to jail, I go to jail. If I land on a chance card, I might go somewhere else. If I land on a community chest, I might go somewhere else. There's no other options for those things. So something like free parking, if I land on free parking, I get my money. If I land on a property, I got to do stuff. Then I think the other phase might be houses and hotels, but we'll do that another day. All right, I'm gonna leave it here. I like the way this is. I like how this is starting to shape up. There's a lot of logic in here, but you can kind of see like each of the major decisions is like a phase of the game where we figure out our logic and what we need to do with it, and we'll clean. There's also kind of a closing, a next turn phase here at the end. We can clean that up a little bit and make it look like this. I always like to zoom out from flows and kind of see what they look like. If they look crazy, it doesn't feel right to me. If it's like crazy twisted soup, you've got a lot of complex logic happening in there. This is pretty linear, and we're lucky because the process is linear. But if it was turning in on itself and things like that, it might be pretty creepy. Also, I could like carve out portions of this and put them into subflows if I wanted to, And maybe that's a good, next step for each of the major phases. There's a lot of linearity here at the front, but I don't know how to get away with that. We just have to set things up. In fact, I think we have some more things we need to set up. So, all right, we'll wrap it there. Code will be updated. Website will be updated, and next week I'm going to Midwest Dreamin' over in Minneapolis, and I'm gonna be talking to people about jobs at Red Argyle, and I'm going to be talking to people maybe a little bit about, you can't do that on Salesforce too. We'll see if maybe we can do a live event from the event with a few people, hang out and talk about things that they couldn't do on Salesforce, or that they did do on Salesforce that people told them they couldn't do. So we'll have a little bit of a break from the code and the build and do kind of an interview style situation. I think that is it, and we'll see you all next time. Hey, we won't be back. We're just turning it off. See ya.